What if I told you that the stars you see tonight died before your ancestors walked the Earth? Right now, above your head, the universe is playing a cosmic trick on you. Every point of light in the night sky is a ghost, an echo from a past that no longer exists. The photons striking your eyes began their journey when mammoths roamed the planet, when Rome was falling, when the first humans discovered fire. And here's what will shatter your understanding of reality. When you look 1 light year into space, you're not just seeing distance, you're seeing time itself. You're looking at the past, frozen in the light traveling toward you at 186,000 miles per second. Today, we journey through evidence that challenges everything you thought you knew about observation, causality, and the nature of existence itself. Prepare yourselves. We begin. In 1676, a Danish astronomer named Ole Romer was studying Jupiter's moons when he noticed something impossible. The moons weren't appearing when they should. They were late, consistently, predictably late when Earth was farther from Jupiter and early when Earth was closer. This wasn't a measurement error. This was the universe revealing its deepest secret. Light has a speed. It doesn't arrive instantaneously, it travels. Think about that for a moment. Every time you flip a light switch, there's a delay, infinitesimally small but real, between the light leaving the bulb and reaching your eyes. In the time it takes light to cross your room, entire quantum events have occurred. But here's where it gets strange. Light from the sun takes 8 minutes and 20 seconds to reach Earth. This means something profound. You have never seen the sun as it exists now. You've only ever seen it as it was 8 minutes ago. If the sun suddenly vanished, you wouldn't know for over 8 minutes. You'd continue seeing it, feeling its warmth, living under an illusion. Romer measured light speed at 140,000 miles per second, remarkably close to the actual 186,282 miles per second. In 1 year, light travels 5.88 trillion miles. We call this distance a light year. And here's the paradox that haunted scientists for centuries. If light takes time to travel, then everything we see is the past. The present, the actual true now, is fundamentally invisible to us. But the evidence forces us to confront an uncomfortable possibility, that our entire perception of reality is a carefully constructed museum of the past. Let's examine what this means with concrete evidence from the night sky. First observation. Proxima Centauri, our nearest stellar neighbor, sits 4.24 light-years away. When you look at it, if you can find it with a telescope, you're seeing light that left that star 4.24 years ago. If Proxima Centauri exploded in a supernova tomorrow, you wouldn't know until 2030. Second observation. The Andromeda galaxy, that faint smudge visible to the naked eye on dark nights, is 2.5 million light-years away. The light entering your eyes right now began its journey when our ancestors were Australopithecus, before humans existed as we know them. You are literally seeing the Stone Age of another galaxy. Third observation. The Hubble Space Telescope in 1995 pointed at what appeared to be an empty patch of sky, no larger than a grain of sand held at arm's length, and exposed the image for 10 days. What emerged was the Hubble Deep Field, nearly 3,000 galaxies, some over 12 billion light-years away. Think about that number, 12 billion years. When that light began its journey toward Earth, our sun hadn't formed yet. Our planet didn't exist. The light traveled through expanding space while generations of stars were born, lived, and died. But here's what conventional explanations can't reconcile. That galaxy, as we see it now, no longer exists in that form. It has evolved, changed, perhaps merged with other galaxies. The reality we observe is a phantom, a light-encoded message from a universe that has moved on. But this is only one piece of a much larger puzzle. The evidence becomes even stranger when we consider what happens when we look in every direction. Imagine standing in a field and spinning in a circle. With your eyes, you can see about 3 miles to the horizon in every direction. You're at the center of a 3-mile circle. Simple. But now imagine doing this with a telescope looking into space. You see galaxies 1 billion light-years away in one direction, 5 billion light-years away in another, 10 billion light-years in a third. You are standing at the center of concentric spheres of time. Each distance is a different era of cosmic history. The first strange pattern: no matter where you look, you appear to be at the center of the observable universe. This isn't because you're special. Any observer anywhere in the universe would see the same thing. They would be at the center of their observable universe, which wouldn't perfectly overlap with yours. The second pattern: the universe has a horizon. Just as Earth's horizon limits how far you can see across the ocean, there's a cosmic horizon beyond which light hasn't had time to reach us since the Big Bang. This horizon sits at approximately 46.5 billion light-years, not 13.8, because space itself has been expanding while that light traveled. The third, most unsettling pattern: in 2022, the James Webb Space Telescope revealed something shocking. When it looked at the earliest galaxies, those forming just 200 to 300 million years after the Big Bang, they were far more mature, more massive, more structured than they should have been. These ancient galaxies, caught in light from the universe's infancy, appear to defy our understanding of how quickly galaxies can form. We are looking at a past that doesn't match our models of the past. The evidence extends beyond mere observation into the realm of existential paradox. What does it mean to exist in a universe where the present is invisible, where every observation is archaeology, where looking outward in space is looking backward in time? The scientific framework that explains all of this comes from Albert Einstein's theory of special relativity, published in 1905. Einstein proved that space and time are not separate, they're woven together into a 4-dimensional fabric called spacetime. And here's the crucial insight: the speed of light is not just a speed limit, it's the speed of causality itself. Nothing can transmit information, influence, or force faster than light. This means every event in the universe creates a light cone, a boundary between what can be observed and what cannot, what can influence you and what cannot. Your past light cone contains every event that could have affected you up to this moment. Your future light cone contains every event you could possibly influence. Everything outside these cones is causally disconnected from you. It might as well not exist because it cannot interact with you in any way. But there's a competing interpretation proposed by physicist Brian Greene and others, the block universe theory. In this view, past, present, and future all exist simultaneously. Time is an illusion created by consciousness moving through a static, eternal 4-dimensional structure. When you look at a star 4 light-years away, you're not seeing its past, you're seeing it at a different spatial and temporal coordinate in an unchanging block of spacetime. Institutions like CERN, the European Space Agency with its Euclid telescope, and the Vera Rubin Observatory in Chile are actively testing these frameworks, looking for evidence that might distinguish between models of time, causality, and observation. This forces us to reconsider fundamental assumptions about simultaneity, causality, and the very nature of observation. If the present is defined by light reaching you, and light takes time to travel, then now is not a universal moment, it's a personal experience, different for every observer depending on their position in spacetime. The implications ripple outward into every aspect of how we explore and understand the cosmos. The Nancy Grace Roman Space Telescope, launching in 2027, will survey 200 times the area of sky that Hubble can see, pushing our observations deeper into the past, potentially revealing galaxies from just 100 million years after the Big Bang. The extremely large telescope in Chile, with its 39-meter mirror, will begin operations in 2028, allowing us to directly image exoplanets and see them as they were when their light began its journey. We might observe continents, oceans, atmospheres, all frozen in light years of time. But here's what this means for us. If we ever detect a signal from an alien civilization, we won't be having a conversation. We'll be discovering an archaeological transmission. A radio signal from a civilization 1,000 light years away shows us that civilization as it was 1,000 years ago. By the time we receive their message, they might have evolved beyond recognition or ceased to exist entirely. And if we reply, our response will take another 1,000 years to reach them. Any exchange of ideas would span millennia, generations, entire epochs of civilization. We are cosmically, fundamentally alone in our present moment. We share the universe with trillions of galaxies, but never simultaneously. We are observers in a museum where every exhibit is light years out of date. But the most mind-bending implications emerge when we follow this evidence to its logical conclusion. Question 1. Is there such a thing as universal now? Einstein said no. Simultaneity is relative. Two events happening at the same time in one reference frame might occur at different times in another. Your now is not my now if we're moving relative to each other. The present moment is personal, not universal. Question 2. If we can only observe the past, can we ever truly know the present state of the universe? The answer is no, not just in practice, but in principle. The universe's present configuration is fundamentally unknowable because information propagates at finite speed. Question 3. What happens at the edge of the observable universe? There are galaxies currently moving away from us faster than light, not by traveling through space faster than light, but because space itself is expanding. The light from these galaxies will never reach us. There is an entire portion of the universe that is permanently invisible, permanently in our causal future or past, forever beyond observation. There could be galaxies, civilizations, even entire cosmic structures that exist right now, but whose light will never reach Earth. They are real, they are out there, but they are eternally invisible to us. And here's the ultimate paradox. When you look at the cosmic microwave background, the afterglow of the Big Bang itself, 13.8 billion light-years away, you're seeing the moment the universe became transparent to light. You're seeing the edge of time itself. But that edge is receding. Every second, it moves farther away as space expands. The observable universe is growing, but the universe beyond it is growing faster. We are in a race against cosmic expansion, trying to see as much as we can before it disappears forever beyond the horizon. The most profound implications emerge when we consider we live in an expanding museum of light, surrounded by ghosts of cosmic history, forever separated from the present by the tyranny of distance and the finite speed of causality. So let's return to our opening question. What if everything you know about observation is wrong? The answer is it is. When you look at the stars, you're not seeing the universe as it is. You're seeing the universe as it was, a vast temporal mosaic assembled from photons that have been traveling for years, centuries, millennia, eons. We know that light takes time to travel. We know that distance and time are equivalent when we look into space. We know that the observable universe is finite, bounded not by walls, but time itself. But what remains unknown is even more staggering. What exists beyond our cosmic horizon? What is happening right now, in the true present, across those trillions of galaxies we've only ever seen in the past? How many civilizations are looking at our galaxy, seeing Earth as it was millions of years ago, long before humans existed? A single light year is not just a distance, it's a window into time. It's a reminder that we are observers in a universe where looking outward means looking backward, where the present is invisible, where reality is constructed from the ghosts of light. The universe is vast, the mysteries are endless, the journey continues.